Welcome student, how are you? I am Dr. MAJHI, teach physics for NEET, Mains and Advanced. Today I will be discussing the magnetic field due to current. First of all, I will be discussing the BIOT-SAVART'S law, and then by utilizing the BIOT-SAVART'S law we have to calculate the magnetic field due to straight conductor and magnetic field due to infinite long straight conductor at any point and at one end of the conductor. Now let's start. First of all, BIOT-SAVART'S law. Suppose this is a conductor carrying current I. We have to calculate the magnetic field at the point P, which is at a distance r from the current element ideal vector. So magnetic field at the point P due to current element ideal vector is given by dB vector equals to mu naught by 4 pi ideal vector cross r cap divided by r square. Okay, the magnetic field at the point P directed normal to the plane containing ideal vector and r vector. Okay, that is in this case is directed inwardly, and mu naught equal to 4 pi into 10 to the power minus 7 Weber per ampere meter is the permeability in free space. Okay, now look at this. So dB equal to, look at this, dB equal to mu naught I dl sin theta divided by r square, where divided by 4 pi r square, where sin theta is the angle between ideal vector and r vector. Okay. Now this law is known as the BIOT-SAVART'S law, and this is the scalar form of BIOT-SAVART'S law. The scalar form of BIOT-SAVART'S law in CGS unit is known as Laplace law. So Laplace law becomes, look at this, dB equal to k I dl sin theta divided by r square. This is the Laplace law in magnetic field. Okay, now look at this. Y dash y be a straight conductor carrying current I. We have to calculate the magnetic field at the point P at a distance capital R from the straight conductor. Now the magnetic field due to current element ideal vector is given by dB vector equal to mu naught by 4 pi ideal vector cross r cap divided by small r square. Therefore magnetic field at the point P is directed normal to the plane containing ideal vector and r cap vector. That is normal to the plane containing ideal vector, normal to the plane containing ideal vector and r vector, that is normal to the plane of the board, and here directed in inwardly. So look at this, here dB equal to, look at this, dB equal to mu naught by 4 pi I dl sin, look at this, this is the 90 degree plus theta by small r square. Look at this, this is theta, this is 90, so this angle 90 degree minus theta, so this angle is 90 degree plus theta. So look at this, this becomes mu naught by 4 pi I dl cos theta divided by r square. This is the magnetic field at the point P due to current element ideal vector. Now from this triangle, look at this, this length small l and this is the capital R. So look at this, small l by r, small l by capital R equals to tan theta. Therefore small l equals to capital R tan theta. Therefore from this condition dl equals to, this is the r sec square theta d theta. So dl equals to r d theta divided by cos square theta. Okay, this is the value of dl. Again look at this. This is the base and this is the hypotenuse. So capital R by small r is equal to cos theta. So capital R by small r equal to cos theta. Therefore capital R equals to small r cos theta. Okay. Now this equation 1, this equation 2 and this equation 3. Now using equation 1, 2 and 3 we get dB equal to mu naught by 4 pi. This is the I into cos theta and dl is the r d theta divided by small r square cos square theta. Now look at this, r cos theta equal to capital R. So r square cos square theta is equal to capital R square. So this becomes mu naught by 4 pi I cos theta d theta into r divided by r square. Therefore dB equal to, look at this, mu naught by 4 pi into I by capital R. This is the cos theta d theta. Okay, this is the final expression of magnetic field at the point P due to current element ideal vector. Now we have to calculate the magnetic field due to whole conductor, this angle theta 2 and this angle theta 1. Therefore the magnetic field due to whole conductor B equal to, look at this, B equals to mu naught by 4 pi I by capital R integration cos theta d theta, and this is the theta 2 minus theta 2 to theta 1. So look at this, this becomes mu naught by 4 pi, this is the I by capital R and this is the minus, this is the sin theta and this is the theta 1 and this is the minus theta 2. So B equal to, look at this, mu naught by 4 pi, this is the I by capital R, this is the sin theta 1 plus sin theta 2. Okay, this is the magnetic field at the point P due to the whole conductor. Okay, now for an infinitely long straight conductor, theta 1 and theta 2 becomes 90 degree. Then magnetic field B becomes, look at this, mu naught by 4 pi, this is the I by capital R and this is the sin pi by 2 plus sin pi by 2. Okay, therefore B equal to mu naught I by 2 pi R. Okay, so B equal to mu naught I, so B equal to mu naught I divided by 2 pi R due to infinitely long straight conductor. Now for a now the magnetic field at one end of a straight conductor, theta 1 equal to 0 degree, theta 2 90 degree or theta 2 0 degree, theta 1 90 degree. In this case magnetic field B becomes mu naught I divided by 2 mu naught I divided by 4 pi R. Okay, now from above discussion we know dB vector equal to mu naught by 4 pi ideal vector cross r cap by r square, and the scalar form of it dB equal to mu naught ideal sin theta by r square, and magnetic field due to straight conductor dB equal to mu naught by 4 pi I by r sin theta 1 plus sin theta 2. For an infinitely long straight conductor, the magnetic field at any point is equal to this, and at one end of the conductor is equal to this. Okay, now we solve some numerical related to this. Look at this, this is the question number 1. Look at this. This is a conductor. Find the magnetic field at a distance 1 meter on the perpendicular bisector position of a conductor of length 10 to the power minus 2 meter. Now suppose this is a conductor of length 10 to the power minus 2 meter and current I 10 ampere flow through it. Now we have to calculate the magnetic field at the point P. Now this is the 1 meter and this is the 10 to the power minus 2 meter. So this length is negligible in comparison to the distance where magnetic field is obtained. Now from this figure we can write dl equals to 10 to the power minus 2 meter, I equal to 10 ampere, and smaller equals to, look at this, and smaller equal to, this is the 1 meter, and look at this, this is the 90 degree. So here theta equal to 90 degree. So using this relation, look at this, dB equal to, look at this, dB equal to mu naught by 4 pi, this is the ideal sin theta by divided by r square. So look at this, this value is 10 to the power minus 7. This is the 10 into 10 to the power minus 2 into sin 90 degree divided by 1 square. Okay, divide by 1 square. So this becomes 10 to the power minus 8 Tesla. Okay, so magnetic field at this point is 10 to the power minus 8 Tesla. Look at this next numerical. Look at this, this is an infinite long straight conductor and this also infinite long straight conductor. Now current through this conductor is 10 ampere and this also 10 ampere. Distance of separation is 5 centimeter. We have to calculate the magnetic field at the midway between the two conductors at the point P. So look at this distance is equal to 5 by 2 centimeter and this distance also 5 by 2 centimeter. Now look at this is the current. So magnetic field due to this conductor is directed downward. So now the magnetic field at this point due to this conductor is directed inwardly. Now look at this, the magnetic field due to this conductor is also directed inwardly. So total magnetic field is the sum of the magnetic field due to two conductors. Okay, so magnetic field B at the point P is mu naught by 4 pi and this is the 2I by R. That is, look at this, mu naught I by 2 pi R into 2 due to two conductors here. So look at this is the mu naught. Now look at this is the 4 pi into 10 to the power minus 7. Now look at this, so this is the mu naught by 4 pi and this is the 4 into I by R. So look at this is the 10 to the power minus 7, this is the 2 into 10 and this is the 5 by 200 because the distance is 5 by 2 centimeter. So this distance is 5 by 200 meter. So look at this, the magnetic field becomes, this is the 0.4, so this is the 0.4, this is the 0.4. Look at this is the 0.8 into 10 to the power minus 4. So this is the 0.8, so this is the 8 into 10 to the power minus 5 Tesla. So magnetic field due to the straight conductor is 8 into 10 to the power minus 5 Tesla. Okay. Look at this, two conductor P1 Q1 R1 and P2 Q2 R2 sends current this way. This is the current I and this is the current I. Now we have to calculate the magnetic field at the point P which is at a distance of A from each conductor. Now look at this person cannot produce magnetic field at the point P and this person also cannot produce magnetic field on this point because the point P is on the extended line of this person. Okay, now we have to calculate the magnetic field we have to calculate magnetic field at the point due to this portion and this portion. Now look at this. P is the one end of this conductor and P also is the one end of this conductor. So now look at this, the magnetic field due to this person is directed inward. So this magnetic field is directed inward. Now magnetic field due to this person is also directed along this direction. So the total magnetic field the total magnetic field at this point is magnetic field due to this person plus magnetic field due to this person. So magnetic field B becomes, look at this, this is the mu naught by 4 pi and this is the I by A into 2, because this person and this person produces same magnetic field at the point P in the same direction. Okay, so this becomes mu naught I divided by 2 pi A is the magnetic field is directed inwardly. Oh, now look at this. Here current is flowing along positive direction of x-axis and we have to calculate the magnetic field at the point 1 meter, 0 meter, 0 meter. That is, magnetic field is obtained at 1 meter from the origin on the x-axis. So magnetic field will be one end of a straight conductor carrying current 10 ampere. So now look at this. Here B equal to, this is the mu naught by 4 pi and this is the I by R. So this is the 10 to the power minus 4 and I equals to 10 ampere and R equals to 1. So this is the 10 to the power minus 6 Tesla. Now what is the direction? Look at this. The current I is directed along Z axis. This is the K cap. And R is obtained on the x-axis. So this is the I cap. Now K vector cross I vector, that is the J vector. So magnetic field B vector is equal to 10 to the power minus 6 Tesla J cap. Okay, understood?